Hello everyone, welcome to editorial video of Codeforces Round 815 problem D1. And in this problem we are given an array of n integers which is zero based index, and what we need to find is the longest beautiful subsequence of the array. Now let's see what the question wants. So we are also given an array B. So array B is the um, array of indexes of the selected subsequence. Suppose we are having uh, 5 2 4 3 1, so the index will be 0 1 2 3 4, right? So suppose we choose 5 4 1, so the B array will be 0 2 4, and this will be the subsequence. And we can see that the um this subsequence is increasing in nature, right? So for what we need to satisfy in this array B is this condition we are given over here, this condition. And what this condition states that a of bp XORed with b of p plus 1 is less than a of b of p plus 1 or b of p, and this must be valid for all p in array B. So this is our condition. Now what we can see that the constraints for n is up to 3 into 10 to power 5, and but the constraint for ai is up to 200 only. And after observation we will notice that 200 is less than 2 to the power 8 and it is greater than 2 to power 7, right? 2 to power 8 will be 256 and this will be 128, right? So now what we will notice that okay, so let's take this thing. Both the LHS and RHS follows a similar pattern, and this is an element XORed with any index, right? Here is the element, here is the index, here is the element again, here is the index. So we'll observe this thing a bit, right? So we notice that ai will be 0 to 200 and aj will be 0 to n minus 1, where n is 3 to 10 to power 5. So we will try to observe ai XOR j's value. Suppose okay, so suppose what I have as j is some binary number, right? I will write the index 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Yes. So what we can see is, now if 200 is in between 2 to power 8 to 2 to power 7, we can state that ai will have all of these things with as zeros. 8 onwards in the left direction will be 0 in ai, right? And for this part, it can be anything, we don't know, question mark, 0 or 1, it can be anything. So what can be the value of ai, what can be the value of ai XOR j basically? So for ai XOR j, this will be copied as it is from j, right? And this will be unknown. Now what is the minimum, uh, what is the worst case, what can be the minimum values of these question marks? The minimum values will be, everything would be 0, everything would be 0 upon XORing, like this is 0, this is 1, this is 1, so it will be 0 0 0 0 0 0 and everything 0. So what is this? In the worst case it will be j minus summation 2 to power I from I equal to 0 to 7. And what is this? J minus 255. right? And in the best case, this will be everything will be 1, right? So in the best case, ai xor j will be, suppose j plus 2, uh, j plus summation 2 to power I equal to 0 to 7, which will be j plus 255. Now we have noticed that the minimum and maximum value of ai xor j will be j minus 255 and j plus 255 respectively. So what we can notice now is, first of all, we'll convert this thing into a much simpler form. So suppose we put bp as I and bp plus 1 as j. So how will this equation look like? ai xor j is less than aj xor I. This will be my equation. Now what I will do is, I'll draw a number line. This is I, this is j, right? So aj xor I wants to be greater than ai xor j. Like suppose, so aj xor I's maximum value will be I plus 255, which is suppose here. And in the worst case, in the most edge case, uh, this value must be greater than this value. So when will the most worst case occur? When this holds a minimum value j minus 255. So it comes over here. So I will apply the condition, and post solving this we will observe that we are getting j minus I less than 255 into 2, which is j minus I less than 510. And this is all what we needed as an observation. Now I'll show you the code. First of all, I am like creating a dp vector and initializing every dp as 1, because if we take only one element, it is satisfying the condition, and the answer will be, the size will be 1. And this answer variable, it is like, it will subsequently be storing my maximum dp of I value. Right now, for all 0 I from 0 to n, what we will do is we will iterate for j, where j is less than like j is from I minus 1 and j is, and any of these two condition holds true. And in this range, if our conditions that is given is satisfied, we will use the dp occurrence which is used in longest increasing subsequence problem, which is simply dp of I is equal to maximum dp of I comma 1 plus dp of j. And we are sure that this whole loop will run at max 510 times. So what will be our time complexity? Our time complexity will be O of n into 510. And after calculation of dp of I, I am storing answer as maximum of answer comma dp of I, and after calculating, after the whole loop ends, I'll simply output the answer. So this was the code of the problem. I hope you understood the problem. Thanks for watching and have a nice day.